Hi everyone, good morning, and this is the second video on COBOL programming. In this video, I'm going to discuss on table handling and primarily, subscript, index, search all these things we will see in detail. Okay. Table is nothing but an array, and what we are seeing here is a table. Okay. And 0 1 level in COBOL we are not supposed to have a occurs class because it is meaningless. 0 1 is the highest level, and that it is not supposed to have occurs. If you code occurs, you will have a compilation error. And so where the occurs is coded, and that is called as table. So WS months is we call as a table. So occurs is 12 times, and the table can have optionally index. Okay. Now let me introduce index and subscript here. Okay, subscript is a working storage item which you can define with S9 of 4 comp or S9 of 9 comp, whatever you want. And it is actually with subscript, when you are accessing a table, it will be converted to displacement and then it is accessed. What does it mean? If I try to access here WS months of a variable which is a subscript that contains a value of 2 or say 3, what will happen is in the runtime, okay, you are given 3, right? So what will happen is the size of the table is 2 plus one occurrence size is 3. So third occurrence you want to access. So what will happen is 3 into 2, which is 6 plus 1, which is a third occurrence starting position. Like this, the displacement from starting of the table is calculated as a 7th byte for third occurrence, and then it is accessed. This is what happens when you access a table using a subscript. And the same thing you are doing with the index. What will happen is the index is internally associated item with a particular table. So this mon.ix index is associated with the table. It has a predefined meaning of mon.ix 1 means it should be 1. Mon.ix 2 means it's 4. Mon.ix 3 means it's 7. This is a predefined and preset data available in a COBOL compilation itself. So what will happen is, so whenever you access WS mon.x, when the same table you are accessing a third occurrence using an index, it will directly go to displacement of your 7th byte and is access. So for that reason, displacement or accessing a table index will be much faster than accessing using a subscript. But at the same time, the indexes are you cannot display the index as such because it's an item associated with a particular table. So you can use the index only 3 operation. They are set, which is for setting a value or incrementing a value. For that purpose, the set command, and perform command. Again, in perform command also you can you want to loop through something, you can use the index. So and then search, that also for lookup of a table. So perform, search, set, only these 3 statements can impact the value of index items, whereas subscript is, it's just like that, just a working storage item. So all operation can be do. You want to do arithmetic operation, you want to do the display, everything it is possible by a subscript. And also you remember that a subscript being a working storage item, if I access the first occurrence of one table, it is converted into displacement with respect to that table and accessed. So with the same subscript I can access another table, then also things will work, because at the runtime only it is counting the displacement and then go and fetch it. Whereas index is associated with a particular table. If I have a definition of WS mon.ix with this table with the same WS mon.ix, I cannot access the other table. If I try to access the other table, what I will be getting will be a unexpected junks, because provided the jobs the 2 tables size is different. If a 2 table size are exactly same, then things may work. Okay. So you need to remember that one table is defined with one index. That index, with that index, don't access the other table. Indexes are allocated and designated for only one table. Okay. Let's understand this. Okay. If I try to do that, what will happen? So what will happen? See, if first table is of 50 bytes, assuming, okay, and it has a index of like mono x. Second table is only of 5 bytes. It has an index of another index. If I try to access the second table using a say 9th occurrence of mono x, obviously it is a out of array. This table, because this table will be accessed with the displacement which is of 10th time of that table, means it will be surely more than 5 bytes, right? So obviously it will try to access the memory in the beyond its limit. So what happen is the program will fail with happen with table you are accessing an item beyond the boundary of the table. With that you will get happen. What is happened? U4087. So that user event you usually get, okay. U4087 is usually out of boundary access in array, okay. And at this time I want to introduce you something called compiler option SS range, okay. So what is SS range is, if you enable the SS range compiler option, whenever you access a item in a table, it will be checked that it is within the boundary. So every time you access a occurrence, first it is checked that whether it is within boundary, and then the data will be accessed and you will get it, okay. That is SS range. And if at all you are trying to access item using an index, that index is beyond the index or subscript, and that is beyond the table size, it is going to happen with U4087. That is SS range. And in production usually SS range will not be enabled, because SS range, for the reason I said, it will slow the operations. So by default production programs would have been compiled with no SS range. What is no SS range? If you compile a program with no SS range, this check will not happen. So whenever you access that index, directly displacement will be calculated, that will be accessed, okay. Same applicable for subscript also. So array boundaries will not be checked when you are accessing items in the array. So in that case what happens is, you have a 10 byte array. For 10 byte array, everything is one time occurring, and then followed by some 5 bytes declaration. You are trying to access a 11th occurrence of an array, you may end up taking from follow-up working storage, okay. Even though because working storage is nothing but contiguous memory location, and your subscript or index is nothing but finding the displacement from start of the table. So obviously it will go and take it up from down the line, okay. So this is called if it is you are reading, it is fine. If you are writing using that occurrence, what will happen? It is going to corrupt the memory. So in real time you may see memory corruptions are happening because of out of array access and population due to wrong index calculations, okay. So usually whenever you do any development in your development environment, make sure you compile your program with the SS range. By default development environment, SS range would have been enabled by your installation itself. If not also, you make sure that you do the work with the SS range compiler option, so that whenever your program logic unintentionally it is accessing the array beyond the boundary, it will happen. From that happen, you know that what is happening, and then you can go and fix it, okay. So that is about compiler option of SS range, okay. Now let's look into the program. So in this program, as I have already seen, I have a month table which is occurring 12 times, which contains values like 01Z, 02F, like this. That is, first two characters is a month number, and second one is the first character of every month, January, February, March, like this. I have a table which is 12 times occurring. Every occurrence is of 3 bytes length. And I have one more table which is number and alpha. 1 means A, 2 means B, like this one table I have, okay. And this is my subscript definition, okay. S904 comp of monsub. And depending on the size of your array, you may have S904 comp or S909 comp, okay. Even if normal numeric item like S904, if you define also, it will work, but since we have already discussed performance wise, always go for a computational items, and in this case for S904 comp, okay. Then what I did, this is a table accessing using the index. So what I am doing is accessing the 9th month. So using the set statement, this mon x is the index associated with the table. So I am setting 9 to that mon x, set mon x to 9, and for subscript I am moving 9 to subscript. Now using index I am seeing ws month num of 9, and ws month first character of 9. So I will be getting the 9th occurrence, which is September, right? So I will get 0, 9 and yes, and subscript the same results I will get. So results are same, but this will be faster because there is no conversion of displacement needed at the runtime, as it is already referred the displacement itself. Whereas here the conversion has to happen on the displacement, as we already seen. So the performance wise this will be slower than this. Okay. Now next what we are going to see is, as we discussed, we try to access using this index other table, the second table. What is happening we are going to see. Okay. So this table index is num x. So what I am doing is accessing the mon sub, the same in subscript. Okay, the same subscript with the 9th occurrence I am trying to access the table 2. This is fine because subscript is working storage item. It can be applied to any table. As we already seen in theory, it will be converted to displacement with respect to that table being accessed, and then it will be accessed. So it will be correctly will come, and this is also will correctly come because it is accessing the table's original index, and this is something mon x. Other table index I am using for this table, the displacement calculation will go wrong. So what I will be getting output of this will be a junk one. Okay. Now for whatever reason you want to we already seen that indexes cannot be displayed. So for some reason you want to once you have done the search, you want to know that which occurrence is displayed, something like that. You want to see that, what you will do is you define a subscript item and set the subscript item to index, and then you display a subscript. In that case what you are really seeing is an index. Okay. So like this you can do a index display for whatever reason you want to do. Assign that to a subscript and then display the subscript. Okay. I think this is good with respect to subscript and index. We'll see the result quickly. This is the result. So accessing the 9th month, I got the result correctly for the first table using index as well as subscript, and the second table when I am accessing its own subscript, I got the result. But when I am using other table index, I got the junk. Okay. I think we are good, and if I want to give a display of index, it is properly coming by assigning to subscript. Okay. So I think we are done. Probably we can quickly refresh a theory. So this is a summary. Subscript is a working storage item. Index is an internal item associated with the table. It means occurrence, it means displacement. 9th occurrence in our example, in runtime it is converted to displacement. How? 9 minus 1 into size of the table, which is 3 plus 1, which is nothing but 25th item. So 25th byte is identified as a displacement, and it is being accessed here. And here it is default by displacement. It will directly go to that byte and access. And it can be used in arithmetic operation. It can be changed only by set, search and index. If you want to display, you have to assign it to a subscript and then display it. And again you can additionally say, as we have seen, one subscript, with one subscript you can access multiple tables, but with one index you can access only that particular table. And okay, and you can have multiple indexes also for the same table. Okay. So I think we are done with respect to subscript and index. Next we will get into a search and search all theory followed by exercise. Okay. Now we have learned how to access the table using index and subscript. Now we will see how to look up the table. Okay, this is the table. In that table I want to look up for something and find out. So what is the known options is perform varying. We can go for our own logic and saying that perform varying ws mon ix from 1 by 1 until that is greater than 12, and perform. Within that you code whatever the search you want to do. For example, month num is equal to 02, then display this. So like this, whatever you want to do, whatever the logic, month number is 6, display this. So any number of condition, whatever the complex logical operation, you can add it, and you can write your own logic within perform varying and perform path, and you got the lookup done in the table. That is a easy and known way of doing. For doing that, you don't need the ascending key, you don't even need the index also. You can go that looping with subscript itself. So perform varying is the first way of doing, and the second way is search. In case of search, it is a sequential search. It will, so we have to, before issuing the search command, we need to set the index to 1, that is set ws mono x to 1, and then issue a search command. Search will do, one after other in the occurrences. So you can do, using a when class, you do the verification against whatever the variable you want to look up with the value, and if it is found, you can come out. And you also optionally code attend class, and that will get a control if the item you are looking for is not found. So that is about search. So search is a sequential search. It will start from the index that is set at that point of time. So before issuing a search, you make sure that you are always setting the index to 1. The third is search all. Okay, and to do a search, your table should have an index. Okay, and to do a search all, your table should have an index. On top of it, it is supposed to have a key, and the table should be shorted on the particular key, because your search all is a binary search. Okay, so and again, when it is a binary search, the when condition also, it's limited. You have to use only the equal condition. You cannot code greater than, less than, all these symbols. And also that should be on the key. Only the search I can do against the month num. I cannot do against month first character. These restrictions are applicable in search all. Why these restrictions are coming in search all, which is not in search, we will come to know if you understand the basic of how search all is working. Okay, so let's get into this sheet. I think this sheet. So this is how perform will look. I'm not sure whether you are able to see it. Okay, this is a perform. If I have 1 to 12 like this, manually I'm navigating is perform. Varying. Search also same thing. Manually it is, but using from COBOL keyword, I'm doing 1 2 3 4 5 6. Whenever the occurrence is coming, it is getting out. Okay, see, even though I coded in search 5 or 6 condition, any one condition it met, it will come out. But in perform, if I coded five different if loop, the loop will continuously go on till you come out with some flag or till it crosses n. So you want to access all occurrences of and all months that has starting with m, means you will get using perform logic, you can get 3 as well as 5. But whereas in search logic, with the 3 it will come out. Again you need to issue one more search where you have to set the index at 4. So further navigation you have to do. So 2 search statement you need to issue to get both 3 and 5. Whereas here in the one perform loop itself you will get both. Okay, this is about perform and search. But search will work binary search. So the here these things need not be started. Okay, it can be anyway 1 5 3 6 whatever it is, it will still work in both these cases. Whereas in search all, the table should be on the sorted order. How it will work is whenever you do a search, like here I am searching 9th occurrence mean, it will directly split the table into half. So half means it will come between 6 and 7. Okay, let's start with the 6. It will compare 6 with 9. So when it is 6 is less than that, it will go to table is ascending, it will go to down half, it will go and check for the next. So what will happen now, from between 7 and 12, it will go and take the exact center. That exact center fall directly, fortunately, on 9. So 9 is compared with 9 and it is found, it will come out with the value. So it is something like directly half the table and then see our compare the item to be looked up with the value of that. And if it is ascending means the number is less, go to down half and continue. Okay, if it is a descending, it is a vice versa case. Okay, so this is how it will work. So here you may have to have what to reach this 9th occurrence, you need to navigate 8 occurrences in both cases. But here in the second IO itself, you got the value. So your search all will be pretty fast, and especially when the search all will be meaningful to use is you have a huge number of items in your search in your table. You always go for a search. If at all sorted value is possible in the table, go for a search all. Okay, the primary condition is should be on a sorted order. And also you remember that in a search all, people sometimes define the table with 50 items and they load only 25 items in a sorted order and try to do a search all, it will fail. It will say item not found, because remember the basic, the table is defined with 50 items, you loaded with only 12 items. So when you are looking for item, directly it will go to 25th is spaces. So what it will do, so 25th is spaces, so and you are looking for item called 28, it will try to go down. but down everything is spaces. So obviously your search all will always fail. So you make sure that whenever you do a search all, your array size is more than what you are loading, the bottom of the array to be loaded with high values. Okay, you have to move high values to your key, and that you need to remember. And also, search all is something, it has if you understand the concept, other things are just information only for you. Because of this reason only we are saying that in the search all, the condition what you are coding is only equal, because you cannot give a greater than symbol. How can I give greater than 9? Then greater than 9 means 9 also, 10 also greater than 9, 11 also greater than 9, 12 also greater than 9. Which one it will pick it up? Search all will always find one occurrence, it will come out of it. So so that is the reason, search all will allow to code only equal class in your when condition. If you code anything other than equal class, you can see that compiler is failing. And also only one condition is possible. You cannot code multiple conditions, or you cannot you cannot multiple when condition, meaningless, because it has to look up only one value. You say that when equal to 4, one class you have written, when is equal to 8 you have written, which way the table will be split, that is also meaningless. So only one when condition is possible, multiple when condition is not possible. And in one when condition also, or condition and all, you should not code. These restrictions are coming. So when you are specifically looking for one occurrence and come out of that, you have to go for a search all. And remember, you want to have like all m's. Okay, all m's I want to get out from using search all mean, that is something not possible in your search all, because search all, once you give item, you are not setting the index, automatically it will set half and proceed. So duplicates of your array you want to take out, that is not possible in search all. Search all, whichever is first satisfied by half, that only, with that it will come out. If it is not found, it will go to attend class. Okay, I think I have covered about everything. So perform will come with highly flexible format, search will come with to an extent flexible format, and search all come with a kind of rigid specific purpose. That is how it is, flexibility. Same way, the performance wise, this is a super, this is good, this is okay. Okay, and I think we are done. So we have to see the syntax and we will see the program. So okay, this is the example. So what I am doing here, I am using a lookup using perform. So perform varying ws mount from 1 by 1 until it is greater than 12. If it is a 9, I am saying that 9, and I may be getting September, which is yes. Okay. So if I want to, as I already said, not only this if loop, I can give 5 if loop, if and end by end if here, all 5 will be checked, and whatever satisfying you will get a display. So multiple searches is possible when you are writing your own logic. And when you want to come out also, you can design one, you can set some flag, or the flag you can code it here, so you will come out. So this is completely free format and user defined. Okay, user logic. This is your perform varying, and this is your search. When you are doing a search, as I said, you want to start the search from first, you need to set index to 1, and then ws search month, attend user saying that search not found, and when condition you are coding and you are displaying it. Here also you can code a multiple when condition, or greater than, less than, whatever you want you do. But remember that once the first when is satisfied, it will be out of the search. You cannot get all the results of multiple conditions. Okay, so that is about your search. And to apply a search, your table should have an index. And third is search all. In the search all month, attend, display, and when month equal, only equal condition is possible, and only one when class can be coded. That is the restriction of the search all. And search all table should have a ascending key or descending key, and that key only I can use in when class for comparing against the values. And if it is found, it will come out. If it is not found, it will go out. Okay, I think we are done. So we will go and see that the output for this. So I got in all cases 9s. Okay, so we are good. So, and I was saying about something like array bound. I did one exercise I forgot to show in the previous slide. This is when you will be getting when you are trying to access out of array boundary. This is when you will be getting. The reference to the table is address is outside the region of the table. This kind of abend you will get if your program is compiled with SS range and you are trying to access a memory or occurrence which is not a part of this table, then you will be getting it append. This append usually when it is coming, it will come with U4087 if I remember. Yeah, what you are seeing is 4087 append. Okay. I think we are done. Thanks for watching. Bye.